Hi, today we're going to talk about quadratic functions. So, a quadratic function is a relationship between two variables, x and y, which is often written in the form of y is equal to ax squared plus bx plus c, where a, b, and c are constants and a is not equal to 0. So, we're first going to talk about finding your y value when you are giving your x value. So for any value of x, the corresponding value of y can be found just by substitution. So let's look at example 1. Example 1 states that if y is equal to 3x squared minus x plus 2, find the value of y when we're going to start with x is equal to 7. So that means that I'm replacing all of my x's with 7. So I'm going to have y is equal to 3 times 7 squared minus 7 plus 2. So if I type that into my calculator as is, I would end up getting 142. So I have y is equal to 142. For the next one, we have that x needs to be equal to 2/3. So I'm going to do the same thing. I'm going to substitute in 2/3 in for x. So I'm going to have y is equal to 3 times 2/3 squared minus 2/3 plus 2. So I'm going to type that into my calculator. So when I put in a fraction, I always use alpha y equals. And once I have typed that in, I will press enter and I will end up getting that y is equal to 8/3 or 8/3. And last but not least, we have x is equal to -4. So I'm going to replace my x's with -4. So it's going to be 3 times -4 squared subtract -4 plus 2. So when I do that, I'm going to have 3 times -4 squared subtract -4 plus 2. And I end up getting positive 54. And if you wanted to, you could have changed that double negative there. So I would have had 3 times -4 squared. And a negative times a -4 is actually a positive 4 plus 2. And you will still see that would have given you 54. Another way that you could have done this is you could have put in your function into y equals. So I'm going to type in y is equal to 3x squared minus x plus 2. And then I'm going to put my graph. So you can tell the calculator to calculate any value or y value for you. You can do it by looking at the table, or you can actually tell it to calculate it based off what you put in for x. So I'm going to press second trace. And when you look at number 1, it says value. Now understand that when it says value, it is referring to the y value. So you want the calculator to calculate the y value. So you can put in any x value there. So for part A, it said x was equal to 7. So if I put x equals 7 and press enter, it will tell me that my y value is 142. If I go back to second trace, calculate, and then I go to and I type in the x value for part B, it was 2 divided by 3. As you can see, I have 2.6 repeated and then a 7. So if I go back out to the main menu and I just type in 2 point and repeat a whole lot of 6's and put a 7. And then if I go to math, enter for a fraction, it gives me 8/3. If I go back to second trace, if I go to my value, I want to say x is equal to -4. And when x is equal to -4, my y value is equal to 54. Okay? So that's how you can do it just by using the graph if you don't want to have to type everything in and then go back and type it in again. So now let's talk about substituting points. So a point satisfies a function if it makes the equation true when it is substituted into the function. So for example number 2, it says determine if the points satisfy the functions below. So we have for part A the point negative 2, 6, and we want to see if it satisfies the equation y is equal to 4x squared minus 5x. So remember, anytime you have a point, that means you have x and y. So I know that x is negative 2, y is 6. So I'm going to have 6 is equal to 4 times negative 2 squared minus 5 times negative 2. And in order for me to see if it makes this equation true, all I have to do is simplify the right-hand side. So I'm going to have 6 is equal to 4 times negative 2 squared minus 5 times negative 2. And that will be 26. And we know that 6 is not 26. So we know that that is false. And we know that this does not satisfy the equation. All right. We're going to do the same exact thing for part B. We have 6 is x and negative 9 is y. So where we have f of x, remember f of x is the same thing as y. So we're going to put a negative 9 there. And that is going to be equal to negative 5 over 4 times 6 squared plus 2 times 6 minus 7. So we're going to have negative 9 is equal to, and if we put it in the calculator, negative alpha y equals 5 over 4 times 6 squared plus 2 times 6 minus 7. We will end up getting negative 40. And because we get negative 40, we know that this does not make the equation true. Another way that you could have done this is if you were to type in these functions into your y equals, you would have had y is equal to 4x squared minus 5x, and you could have looked at the table. So for part A, the x value was negative 2. So if we go to negative 2, we see that the y value is not 6, so that will let us know that that point does not satisfy the function. For part B, you would have typed in the function negative 5 over 4 times x squared plus 2 times x minus 7 and went to the table. And we wanted to see that when x was 6, y was a negative 9. And we see here that when x is 6, y is equal to 40. So we know that it is not. A point that would lie on the line that would satisfy B would be 2, negative 8, because it lies on that point. And we already know that if we were to substitute 2 for our x here, it would give us the negative 8. Okay, so basically plug your point in for x and y, simplify each side, and if the sides are equal, it is a solution and it satisfies the function. If it is not equal, then it does not satisfy the function. So now let's talk about finding x when given y. So when substituting a value for y into a quadratic function, it makes a quadratic equation. You can solve a quadratic equation by factoring, completing the square, the quadratic formula, or graphing. And for the purposes of this class, we are going to look at doing it by graphing. So for part A, it says, if y is equal to x squared plus 4x plus 7, find the value or values of x when y is equal to 3. So I'm going to substitute in 3 for y. So I'm going to have the equation 3 is equal to x squared plus 4x plus 7. So if we solve it by graphing, you should already know that we put our left side into y1 and we put our right side of the equation into y2. So I'm going to have y is equal to 3. And then I'm going to have y is equal to x squared plus 4x plus 7. And when I graph them, this is the graph that I get. Okay, so what I'm going to do so I can make sure I see clearly is I'm going to zoom in. So I'm going to press zoom and I'm going to go to 2. And then I'm going to scroll up a little bit before I actually press enter, because I want to zoom in at approximately where the two colors cross. So it's going to be somewhere near that minimum there. So I'm going to zoom in this area and press enter, because I want to see how many times it actually crosses, if it crosses more than once. And it looks like to me it only crosses once. So when I press second trace, I want to calculate their intersection. So I press number 5 and I'm going to press enter 3 times. And as you can see here, it says my intersection is negative 1.9999999, and then the y is equal to 3. So what I'm going to do is I'm going to look for this information in the table to see if it is true. So I'm going to press second table. And then I want to see where the y value equals 3. So as you can see here, I want to see where the two colors meet. And as you can see here, where x is negative 2, they both are 3. So I know that negative 2, 3 is my answer. So that is my intersection. And the value of x that it happens at is x is equal to negative 2. That is my answer there. All right. So now it says for part B, if y is equal to negative 5x squared minus 9x plus 12, find the value or values of x when y is equal to negative 2x squared minus 25x. So I have that y is equal to negative 2x squared minus 25x. So I'm going to substitute y in the first equation with negative 2x squared minus 25x. So I'm going to have it written down like this. So negative 2x squared minus 25x is equal to negative 5x squared minus 9x plus 12. So I'm going to put my left side in y1 and put my right side in y2. And then I'm going to let the calculator calculate the intersection. All right, and when I graph it, this is the way my graph is going to look. Now, I can't see my full complete graphs, and I see like both of the colors, but I don't really see it good. So I'm going to hit zoom, and I'm going to go down to zoom 6 in order to put it as a 10 by 10 graph like I'm used to seeing it. So zoom standard. All right. So from here, I see more of my red graph, which is y2, which is my right hand side, but I see less of my blue graph, which is my y1. So now that I'm here, I'm going to zoom out just a little bit so I can see a little bit more. So as you can see here, I see that these two graphs cross each other somewhere in the area of where the blue and the red are. So then I'm going to zoom in, but I'm going to zoom in. I'm going to scroll up a little bit so I can zoom in a certain area and press enter. And we see that these two graphs only cross once. So I'm going to press second trace, and I'm going to highlight intersection. And I am going to get as close as possible. And then I'm going to press enter 3 times. So I see that my intersection is at negative 2/3, which is the x value, and the y value is going to be 15.77 repeated and then 8. So from here, I can see that my value of x is only 1. It's going to be equal to a negative 2/3. So sometimes you may have 1, sometimes you may have more than 1, sometimes you may not have where they intersect. So now let's look at how to graph, how to make graphs from a table of values. So the parent function for quadratics is y is equal to x squared. The curve formed by graphing a quadratic is going to be called a parabola. That is the name of the curve. And the graph can be drawn from a table of values. So for instance, we have a table of values below, and you have a graph, and there are some things that you need to notice. So what you need to notice is that the graph is going to open upward, which is why you have the arrows pointing up. The graph has a vertex, which is at 0, 0. And the graph is also symmetric about the y-axis. And we know that it is symmetric about the y-axis because that vertical line where the y-axis is splits that parabola into 2 equal halves. And from there, we can see that f of negative 3 should be the same as the f of positive 3. Or, yes, positive 3. Okay? Remember, because the f of x means y. I can also see that the f of negative 2, which is the y value when x is negative 2, should be the same thing as when the y value of, or excuse me, when the x value of this function is a positive 2. And last but not least, I see that f of negative 1 should be the same as f of positive 1. Okay, so example 4, it says draw the graph of y is equal to x squared minus 2x plus 3 from a table of values. So anytime we graph a function from a table of values, we normally have negative and positive x values. So we normally use 0 for the center number, and then we go up from 0, and then we go down from 0. That's just standard where we normally start. But you want to go up, you want to have some negatives and some positives. So what I'm going to do is, so that I don't have to substitute each of these x values in separately, I'm going to put the function into y equals in the calculator. And I'm going to look at the table of values so that way the calculator does the work for me. So when I look here, I see that when x is negative 3, the y value is 12. When x is negative 2, the y value is 5. When x is equal to negative 1, the y value is 0. When x is equal to 0, the y value is negative 3. When x is equal to 1, the y value is negative 4. When x is equal to 2, the y value is negative 3. And then when x is equal to 3, the y value is 0. So all I would have to do here is literally plot these points. So negative 312, I can't plot because I can't go up high enough, but I can plot negative 2, 5. I can plot negative 1, 0. I can plot 0, negative 3. I can plot 1, negative 4. I can plot 2, -3. And I can plot 3, 0 based off that. Now, one thing that you should also notice is if I look at the point -2, 5, I would know that that would end up going for x is equal to 4 as well. So I know that this will be my next point because remember, your curve is symmetric about the axis of symmetry. And remember, the axis of symmetry goes through the vertex. So that is the axis of symmetry. And as you can see here, this point is the same distance away from this point. This point is the same distance away as this point, so on and so forth. All right, so now you can connect these points with a smooth curve. And it does not have to be perfect, but that is what the points are for. So we can start here and we can just go down and then come back up like that. All right, so if you have any questions on graphing quadratics, let me know and I will be more than happy to assist you. You have a great day.